Today's lesson is on the quadratic formula. This is something that you definitely did in Algebra 1 a lot. So, do you remember what the quadratic formula is? It is the opposite of b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. So, when you do this formula, probably when you were in Algebra 1, you dealt with fairly nice numbers, or you got decimals and rounded. We're going to be using this formula and getting 3 different types of solutions. Okay, so rational solutions come from when you have a perfect square under your square root. And you can simplify it down and you get pretty nice numbers. So sometimes they're integers like 2, -7, or they're fractions, but they're nice fractions, 3/4, 1/3. Nothing too scary. This is probably what you did a lot in Algebra 1. Now, irrational solutions you might have done before as well. This is when we don't have a nice number under our square root, so we're left with this square root. So maybe we have like 3 plus or minus, so there's your first term, your plus or minus, and then we have like the square root of 5. So you could type that in your calculator and get a decimal and round it, but what we're going to do is just keep things in exact form like this. Maybe we have -2 plus or minus the square root of 3. So both of those are irrational solutions. Irrational just means that a decimal goes on and on forever with no repeating pattern. Okay, complex solutions. This will be when the number under your square root is negative, so we have to deal with imaginary numbers. So maybe this one would be 3 plus or minus 4i. Or sometimes there's a combination where you still have your square root and you have I. So maybe you'd have 2 plus or minus 3i square root 7. Okay, starting out, I've got 4x squared equals 11x plus 20. And I'm giving you, spoiler alert, we're going to have a rational solution for this one. Okay, before you can do the quadratic formula, this has to be equal to 0. So let's move these terms over by subtracting them. So 4x squared minus 11x minus 20 equals 0. And now let's plug them into the formula. All right, so opposite of b. So x equals, let's go positive 11 plus or minus the square root. So b is negative 11 squared minus, and I like to put all of these in one set of parentheses, 4 times a times c. Doing it this way, I think, just kind of helps avoid some silly mistakes when you're calculating. All over 2 times 4. And now what I'm going to do is just simplify underneath the square root and simplify the denominator. So 11 plus or minus the square root, 11 squared, that's always going to go to a positive, so 121 minus, and then 4 times 4 times -2 is negative 320, all over 8. Okay, so x equals 11 plus or minus the square root of, now 441 over 8. Now, the square root of 441 is a perfect square. So this goes to 11 plus or minus 21 over 8. Now, that plus or minus simply means we're going to have 2 solutions. One where we do 11 plus 21 divided by 8, and one where we do 11 minus 21 divided by 8. So 11 plus 21, 32 divided by 8 is 4. So 4 is one of my solutions. 11 minus 21 is -10 over 8, which simplifies to -5 over 4. Okay, let's do another example, and this time we'll be left with an irrational solution. Let's start with 8x squared plus 8x plus 3 equals 6. I need it equal to 0, so I will subtract 6 on both sides. So 8x squared plus 8x minus 3 equals 0. And now let's use the formula. X equals the opposite of b, so negative 8 plus or minus the square root of 8 squared minus 4 times 8 times negative 3, all over 2 times 8. X equals, I'm going to break down just the square root here, so negative 8 plus or minus the square root. 8 squared is 64 minus 4 times 8 times negative 3 is negative 96, all over 16. Okay, so now x equals negative 8 plus or minus the square root of 160 over 16. So I'm very confident that most of you will be able to get here, no problem at all. Now it's the tricky part, is simplifying this down. This is the part that students tend to get angry at. So let's simplify this. The square root of 160 can be broken down, think 16 times 10, which is 4 times the square root of 10. So x equals negative 8 plus or minus 4 square roots of 10 over 16. Okay, in this part, if you get this far, awesome, awesome. We technically can do one more step. When these have a common factor that can be simplified with the denominator, we can factor out a GCF. So they have the numerator, they have a 4 in common, so I'm dividing a 4 out. So I'm left with negative 2 plus or minus the square root of 10 over 16. And now you can simplify that, which is negative 2 plus or minus the square root of 10 over 4. So this is the ultimate final answer, simplified down all the way. Okay, last example. This time we will have complex solutions. So I've got 10x squared minus 10x equals negative 10. Let's add 10 to the other side. So 10x squared minus 4x plus 10 equals 0. And here we go. The formula, opposite of b, so positive 4 plus or minus the square root of negative 4 squared minus 4 times a times c, all over 2 times a. Let's simplify the radical down. 4 plus or minus 16 minus 400 all over 20. So 4 plus or minus the square root of negative 384 over 20. So the negative in Algebra 1, you probably stopped and wrote no solution, but now we're going to simplify it down using the idea of imaginary numbers. Okay, so this square root can be broken up into, I've got negative 1 times, and I'm going to help you out with this one. You can break it up into 64 times 6, because that's a perfect square, which would come out as 8i square root of 6. Okay, so 4 plus or minus 8i square root of 6 over 20. If you got that far, awesome, awesome. Last step, look at these terms. Do they have a GCF that could be factored out and simplified with the denominator? So if I take a 4 out, I'm left with 1 plus or minus 2i square root of 6 over 20, which that can simplify to 1 plus or minus 2i square root of 6 over 5. Final answer simplified all the way. So there is your video on the quadratic formula. I think a lot of you will be able to do the first half no problem and get here and probably here. That's that final simplification process that I know gets a little confusing, but we'll work on it together. Good luck with your lesson.